Hey there, welcome to today's video where we'll be diving into a fascinating technical problem. So, imagine you're implementing an ILockBytes interface in C++, specifically to save iStorage as a byte array. The concern here is whether you should implement LockRegion and UnlockRegion methods, even if your program won't be reading or writing ILockBytes memory concurrently. The question is, can another program or the operating system try to access this memory at the same time? Sounds like a head-scratcher, right? Let's unravel this together. In the solution provided, it's pretty clear that we can determine the lock type supported by an ILockBytes implementation by looking at the grf lock supported member of the stats structure returned by ILockBytes. Stat. A LockRegion implementation can choose to support all, some, or none of the lock types. For unsupported lock types, the implementation should return stg_e_invalidifUNCDON. So the key takeaway here is to implement ILockBytes. Stat that sets 0 to stats, grf lock supported indicating no locks are supported, and also implement ILockBytes. LockRegion that returns stg_e_invalidifUNCDON. Simple yet effective, right? In summary, when dealing with the ILockBytes interface in C++, it's crucial to consider whether concurrent memory access might be a potential issue. By following the recommended approach of setting grf lock supported to 0 and returning stg_e_invalidifUNCDON in ILockBytes, LockRegion, you can avoid any unexpected conflicts. And there you have it, problem solved. I hope you found this video helpful and insightful. Don't forget to subscribe, like, and leave a comment below with your thoughts. Until next time, happy coding!